After changing the mean of row number 10th observation, we'll move toward the second. So it's row number 16. In the data, we have row number 16 value equal to 14.932. We replace it by taking the mean of 3 observation at the treatment number 4, where both A and B are at high levels. So let's do in the calculator. I will add up these 3 observations. Got 44.224 divided by 3. I got 14.741. So we will replace the 16th observation with this 14.741. So here we got 14.741. Now we'll go towards the third value. So third observation that is deviated is in row number 8. Let's move towards 8th observation. Sorry, it is 14.921. So the 8th observation is 14.921. We will take the mean of this 14.888, 14.415, and this value has been already replaced. So we will take the new value in replacement of this 16th observation. Let's do it. After addition of these 3 values, I got 44.044 divided by 3. We got 14.681. So here it go 8 value 14.681. Now we'll check for other. So the other value we are checking is it row number 4 and row number 15. Let's deal with the row number 15 first. In the row number 15, we have this value at extreme level is 14.878. So we will take the mean of first 3 values. So these are the 3 values. So after changing numerous values, let's check whether there is any effect on the graph or not, or we have to do further work on it. So go to Factorial, Analyze Factorial Design, click on this last C12 column, click OK. Now go towards the results. We have to see the graphs. Oh yeah, now it's good one. Now the data is following the normal distribution. You can check the both plots of the residual are somehow following normal distribution. And now we move towards the third assumption. The data is there is independence in the data. The data doesn't following any cyclic patterns, or there are no 6 or 7 points going towards continuously towards the upward or towards a downward. So somehow you can say equality of variance is also satisfied. So this table of coded coefficient, it will tell us what's the effect of factor A, B and interaction term. A has a positive effect, B has also positive effect, whereas interaction term has a negative effect. This column coefficients will give us the regression equation. So you can see it here beneath. This is the regression equation we got from the coefficients. Now after going through this table, we come towards model summary. Model summary is telling us that 80.44% variation in the epitaxial layer thickness has been explained by the factor A and B, and we have R square adjusted value equal to 75.54. That's a very good value for the R square adjusted. Actually, R square adjusted value only tell us the variance explanation explained by the terms that perform well. So a slight decrease from the R square is telling us or giving us a hint that there is some insignificant term in the model. So let's come towards the ANOVA to check which term is significant. So now we will check over term A, P value is 0.806. It's insignificant, so that's why our R square adjusted value has been decreased. B, factor B is significant, also the interaction is insignificant because the P value of the interaction as well as factor A is greater than 0.05. that is our threshold value or cutoff value or alpha value. Now we will draw the main effect plot. Go to stat, then ANOVA, then main effect plot. In this we have to select our new data that has been shown in the column C12, then select the factors. We have only 2 factors, A and B. Click OK, and we will get 2 graphs. Let me minimize it. So these are the 2 graphs. You can see it here. From going from the low level of factor B to high level, there is a significant increase in the response variable. However, for the factor A, changing the level isn't affecting the response variable too much, so that's why it is insignificant. Now in the last we will draw our interaction plot. So go to stat, ANOVA, interaction plot. Again, select the response variable shown in the column C12. Select the two factors that are A and B. Click OK. And now we got this interaction plot. After this, we will perform the regression analysis in order to check whether our model is good or not. So responses, then in the predictor select A and B, click OK, and after this you will get the results. So in the analysis of variance table for the regression analysis, the p-value for the lack of fit is greater than 0.05, that is 0.668. It can be interpreted as that our model hasn't any lack of fit, or it means that our model fitted the data in a very good way and we can use our model for the prediction of the values